Me, Shwarajahan Tusha from Daffodil International University. Today we talk about understanding the AES key expansion. Advanced Encryption Standard short form is AES. Now we need to know what is AES. The AES is a symmetric box cipher chosen by the US government to protect classified information. AES is implemented in software and hardware throughout the world to encrypt sensitive. It is essential for government computer security, cybersecurity, and electronic data protection. Since AES puts data through multiple encryption rounds and split a message into smaller blocks of 128 bits, it is more secure and reliable than other symmetric encryption methods. Now, key expansion. The AES key server as a linchpin in the encryption and decryption process, the advanced encryption standard. In encryption, the key transforms plain text to ciphertext, rendering it illegible and unauthorized process. Conversely, during the decryption and same key reverse this process, converting ciphertext back into its original plaintext from the key can be of different lengths 128 bits, 192 bits, or 256 bits depending on the desired level of security. Expansion key, we need three things. Those are original key, subbytes, and round constant. Now we move to code to understand. Here is our code. In this code, we at first see two methods, sbox and archon. Those are contain pre-demarcated value, so we will skip them and go to the main method. In main method, we store the key in original variable and round num is 10, declaring round key, so we store the value of key expansion method in it. By using for loop, we print the output by iterating every round. Now those are our main part. In our main part we can see that at first a public static byte key expansion class. In this method takes the original encryption key and the number of rounds as input and returns a 2D byte array where each row represents a round key. Now here we can see that int key size equals to original key. The lines determine the size of the original key and the size of expanded key in bytes, each round key 6 byte long. Now in these lines, here initialize the round keys array to store the round keys. It has dimension num round plus 1 into 16 where each row represent a row round key. Now copies the original key to the first row of round key. Now the loop, this is a for loop, iterates over each round starting from the second round. Now here we can see that byte third bracket pre round key. It is retrieves the previous round key. Now temporary storage for round routing bytes. Routing and substitution bytes are routed and substituted using the AES box. So here we can see a XOR first byte of with a round constant. This is archon and based on the round number. XOR with previous round key. XOR with here we can see that also a for loop. This is for our previous round key. Now the new round key generated using a combination for XOR and operations and shifting. Now here the generate round key is stored into round keys array. Finally, the round keys array containing all the round keys and this is returned. This process repeat for each round until all the round keys are generated. These round keys are then used in AES encryption and decryption process. Now we see our output. Here our code is running and see all the outputs. Here we can see that 10 encryption key. So that's it. Thank you so much for watching this video. I guess you guys all understanding this code.